So we're gonna continue off my previous research on lattice structures and improving a material's ballistic performance based on the geometries that we can basically configure these into. And the previous research that I did was just going up against a 22, which is still actually, surprisingly, I know that 22 is kind of laughed about in some cases, but that's actually a lot of energy to be stopping with hobbyist resins like I was using. So I was just using a standard SLA printer. And again, these printers are just designed for things like figurines for D&D and whatnot, never intended for engineering use case, which is why I was still pretty pleased to see the results that I got, which is why I was able to still infer my research enough to have PCBWay print out of steel one of those lattice structures. And it did perform really well in that armor plate that I did, beating out traditional level 4 armor plates for not just the power it was stopping, but for how many multiple hits. Typical level 4 plates are only rated for 4 rounds of 308 or 7.62 AP, one each corner and center. And then this one stopped a total of 17 rounds, including 2 300 Win Mags close range, which level 4 are not rated for. So with that being said, if you want some metal 3D printed parts, I would absolutely recommend PCBWay. They had great precision, and obviously the part was incredibly strong. So again, it's just a reminder to take the research that's presented and think about it beyond just the medium that I'm printing it in. Think about other use cases or how it could be embedded with other materials, and that's just, how you take research. That being said, what are lattice structures? How do they make it better? Just to really sum it up, if we have a solid cube like this resin block here, and I was to shoot this, what happens is that the material in here has nowhere to go. The round hits it and it will just shove it out the back. And with something like resin that's brittle, what you'll actually see is it essentially just fractures into large chunks and is totally useless for repeated hits. So it's not good at all. But a lattice structure can basically allow energy dispersion throughout the structure via the propagation of a lot of small deflections that can occur throughout the designed lattice, such that more of the material can be contributing to stopping the round, basically allowing shear, compression, and tension-based forces to all contribute more effectively to stopping the round. So now we're gonna go over and do some ballistic tests of these panels, but a disclaimer, don't try this at home. We are doing this in a safe area, and of course, following firearm safety procedures. Now, I did want to call out at the time of this recording, it's totally legal and perfectly kosher to have a brace on this platform. I just have it on here so I can make sure that I have consistent tests. But of course, if any local laws or regulations change, I can easily detach this and have it destroyed in accordance to those, if anything changes in the future. It did hit a little bit lower, so the sight needs to be raised, but I'm not going to do that quite yet. I'm going to shoot the other cube in the same spot just to make sure we have a consistent test. It didn't do very well at all. We got a couple large chunks, a bunch of small pieces in there. It didn't effectively transfer it. We just got that energy dispersion through these large crack lines and then darted a couple inches into that clay. So the impact that we see is much more spread out. More of the structure was trying to stop the round, and it did much less damage as far as penetration goes into the clay. But I want to continue this research doing more resin-printed tubulines that can be a lot stronger, and this is where the Form 4 machine comes into play. Now, I've had my eye on Formlabs for a while because they have quite a lineup of very interesting resins, a lot of different characteristics, whether it's fireproof or they have some that are flexible. But these are the two that I'm trying today. I'm going to try Durable Resin V2 and I'm going to try the Tough 1500 because those seem like the best options for these lattices. Now, I don't expect that any of these are going to stop the 5.7 period. It just has a very high penetration capability. But I do have some 7075 aluminum, which is an aluminum alloy that's known to be very strong. So I'm likely going to have to put 1 or 2 layers of that in front of these lattices, and we'll basically use the lattices as a final line of defense or a really strong impact pad. That being said, I do expect that the resins to stop the 22. I just don't know what degree yet. First, we're going to set up the resin tray. Simply just drop it in place, lock it in, and then you remove the UV filter on top. We're also going to install the wiper. This is going to make sure that the resin is evenly distributed throughout the print. And then I did attach the print head up above. But this is the full set with the wash, cure station, Form 4, and 3 liters of resin that they sent. Now we're gonna go through the basic setup. Really intuitive here. It walks you through step by step. And then you can insert the resins by simply venting the cap and dropping them in place. The printer will monitor the weight of that to know how much is left. And that's all there is to get this up and running. Now I did of course install Preform. This is Formlabs Slicer program. And I just dropped my lattice in there. And this app is also a testament to their engineering or even programmers' abilities. It was able to patch my my model way better than Chitubox or Lychee slicers have been able to, because they can have some holes in those mesh I have to tune, but this one just worked. It did an awesome job and even has a one-click option, which has worked for me every time I've printed with this thing. None of my prints have failed with this, and even when you swap out the resin, the printer knows what type of resin it has loaded up and relays that to Preform so that Preform automatically applies whatever settings are optimal for the given resin that's loaded, making this by far the most polished and tuned printing experience I've ever had. Like, every little detail they've thought about and tuned really well. Another unexpected piece is it also shows you at the end of the print exactly how long to wash and cure your part for. No more having to hammer and scrape your parts off, simply push these in and it pops it right off. And they also sent me another resin tray, so I have one for each type of resin. This way, when I swap resins, all I have to do is pull one tray out, put the other tray in, and they give you stickers as well so you can label them accordingly. Now, just grabbing the backing of the support material and squeezing it, I can feel that there's pretty good stiffness on the durable resin, but it's really flexible. It's not brittle at all, which is pretty encouraging for something that's going to be impacted. Whereas the Tough 1500 is definitely stiffer, but it is brittle. It actually broke with a similar test. So we'll see, maybe the durable does better, but we're gonna wash these now. Then of course I cured it to the specs, and we now have our two lattice structures for testing. Now the durable print has a really neat, like, opalescent look to it, but let's go ahead and shoot it and find out for sure. Okay, so we see the round entered in the face, a little bit of cracking, so it did hold together pretty, yeah, okay. So we have a little bit of backface deformation here, but clearly their tough resin is tons better than the alternate stuff that I was using. So let's go ahead and switch over to the durable and see how that does.
There's no way. That is stopped completely on the surface. It's literally sticking out of the material. And there's no backface deformation.
All right, since that did so good, we're actually gonna shoot it again because there's no fracturing. So let's see how it handles another impact. No way. Dude. Taking two shots like that, I mean, there's a little bit of cracking going on right between them, but right between there's a little fracturing, but still, to have the second one sticking out even further than the first one in that close a proximity for something that's 3D printed, oh, that's disgusting. In a good way. Let's try something that's not the 22. Let's bump this up to the 9mm full metal jacket. Now, I know that this is gonna go through that 20mm of material for sure, so I actually, just for kicks, printed another one. So we have two of these 20mm lattices, and I'm still reusing the one that we shot twice with the 22 because it just had one little crack in it. And we're gonna see what happens. So obviously, yeah, huge hole, but the round is totally intact down there. The round came through, and then I actually just shoved this out of the way, so it came up, and it just darted, and then it darted downwards. So it came in, and obviously, big cavity here, but it's funny because it's totally intact, because it's going through much softer mediums, of course. So we know that of these two resins, durable is definitely the best. So I'm gonna keep tuning for this one in particular, but 20mm is way too thick to be stopping at 22. So I'm gonna thin this out to just be 10mm thick. And I'm actually gonna do a technique that I've wanted to do with these lattices for a while now, which is doing a gradient-based approach. So materials with gradient, whether it's via composition or the actual structure itself, can exhibit optimal behavior for certain loads. But what I'm gonna do with this lattice is adjust it such that the node sizes scale back the further we get into the actual plate. Now in 10mm, I can only fit 4 layers here. And we're gonna start with the front face having a much denser weave to impede the penetration, and then each layer going deeper, the node count is essentially reduced, but the bridges are then thickened. So we get a very strong backing that's gonna resist cracking and support that denser face in a gradient-based approach. Because again, in engineering, if you have sharp transitions, those are where things tend to break. Now after printing this out and cleaning it up, and looking actually pretty neat, you can visually see that denser pattern in the front versus the thicker, coarser bridges in the back. So let's go ahead and hit this with that same round. I don't know, I mean, 10mm is pretty thin. Oh, it did stop it. So we did get some, it actually knocked a chunk back. We got that Hertzian cone, that classic shape did form there. Now, just to compare how strong this durable resin is from Formlabs, I printed out more of these 10mm cubes, but with the general resin printer with hobbyist, ABS, and regular resins. So John didn't even get a chance to shoot this one down here because it popped off. But again, this is just a .22 long rifle. This is what it's doing through those 10mm thick resin ABS-like cubes with typical hobbyist resins. Now this one up here is your most common resin. This is like an 8K resin for figurines or whatnot, like here. And you can see it did the worst. That's the largest hole, which is funny to say because these are devastating nonetheless. And these are the ABS-like. So absolute garbage for any sort of ballistics, which is why this is still impressive. This is the Formlabs at the 10mm, and it still stopped it. So the ultimate goal for this initial research is the 5.7. That's my target because it is harder to stop than the 9mm, which means that I can already smell the comments saying, but the 9mm is more energy. So it must be harder to stop. It's not the case. And just to prove my point, it takes like an hour to make. So I made a very basic composite panel. So there's no infills, nothing special with this. But I'm gonna shoot it with a 9 a couple times, Full Metal Jacket, and you're gonna see that it's gonna be stopped each time. And I'm also gonna shoot it with a couple Full Metal Jacket 5.7. And you're gonna notice that both of those are gonna puncture through with no problem. All right, point it up, it's unloaded. So there you go. Got stopped. Now, yes, this would hurt, obviously, but the point is just showing that you can stop it with much less. All right, open chamber. And there it is. Okay, I got the 9.57, and we're gonna get the 9 in there again just to show you that it wasn't weakened in that nearby area that let the 5.7 through. Ready? Stuck on here. But you can see again, got the same pocketed shape as before. And this is the hole that it left. You can see it's quite large, and it did bounce all the way back, and then it left a pretty good sized dent in the plywood right here. That's where it dented, and then chucked back out. So you can see lots of energy still here. You know, you can put pretty much 2 hands in this hole. We are going to do some ad hoc testing with some aluminum here. I'm gonna start with 2 layers, so it'll be 6mm total, 2 3mm layers, and then we'll either go up or down depending on how the test goes. The minion is back at work, not paying you overtime.
Only regular time.
Yeah, I know,
That's a good call.
just locking this in with pushing that into the foam. Yeah. Like pushing it, driving that through. A little bit of duct tape, plate, and foam. Vegetable oil. Yeah, no, I think that aluminum stopped it, which is crazy. I can't believe that stopped the 5.7. Yeah, no, it's, dang. I mean, it shoved it in there. And it looks like it broke a little corner off here. Oh, but this is some...
Well, it is an alloy.
Yeah, this 7075 is clearly some impressive stuff, yeah. Wait, no, it broke it here.
Yeah.
Broke it here. Oh yeah, no, that's a mess. There it is. But you can see the round. See it? Look at right through here. You can see it right back there. Right. Let's see if I get my hand out of the way here.
I'm blocking
Sorry.
the light.
Right there. There it is. Yep. It just pieces though. Like
Between 1 and 2.
it does. Yeah, you need that one little bit of backing. It just bored right through that.
That'll
And
do
yeah,
it.
once it got through this metal, it was no test. So we now know that 2 layers is required for the 5.7, but just out of curiosity, I'm gonna put one of these aluminum plates in front of the plywood and shoot it with the 9mm to see if 1 is sufficient for that caliber. So it's right there, and it actually didn't tunnel through like our 5.7 did. It ended up actually breaking off large chunks because it is a bulkier round, and it did shove some of these little pieces of the metal back, and then there's the ball, and it left the jacket behind stuck in the aluminum panel, and it's really in there. So now my immediate idea is that I could use these in custom shapes as pads along my back, and also to help hold the holsters for my spinal battery cells away from my back. And then that got me thinking, I wonder if shooting one of these cells with this pad behind it would be enough to stop something like the 9. I really don't think it would stop the 5.7, but I mean, they are pretty thick, and depending on how densely they're wrapped, I might get an unexpected result. You just never really know with ballistics what you might see. My hunch is it'd tear right through, but I think I'm gonna do that for my next video actually, because it shouldn't be too much research. I just have to make some custom pads with these lattices, so I'll have to mess with, warping these panels into custom shapes while retaining the geometry. But beyond that, it should be a pretty quick turnaround. I don't expect them to catch on fire, but again, you never know.
Okay, so again, the 2 plates is really what it takes. Despite that pretty sharp push out the back here, it didn't actually fracture this material. What's crazy is it seems like it actually shoved clay through the lattice because there was so much pressure. See how this clay is showing up here? Obviously there was no clay between this, so it literally squished clay through this tight multi-layer gradient. Pull this back here, and you can see that, yep, so this did push out the back as well. It transferred some of that energy back. But the good news is this is not fractured at all. So could totally take some repeated hits here. So I hit it on the lower side, so that's where it struck. And then there's the dent. Definitely a little bit lower shot. I mean, it's pretty challenging with that silencer on there because it totally blocks the iron sights. And it did knock off a chunk here. It obviously did not penetrate though. It was just a lot of force, and it was, again, a little bit lower. So it was a lot of force at the edge of this, so it was unsupported, and we did get that little bit of crack here. So we got a bigger dent as it pushed down and away. So the aluminum is doing the heavy lifting, and of course you would want some sort of fiber composite or something on top of this to reduce the spall and ricochets that happen on plain metal.
Now, if you want to mess around with these yourself and print them out with your own resins or FDM printers, check out my Patreon. I've got several different varieties up on there. And the 3 varieties that I have up are a Schwartz P-like structure, a hexagonal weave, and a cylindrical hexabridge style. And I've got 2 samples at different thicknesses, and then you can also download a 110 millimeter panel that's 14 millimeters thick of each of those as well. And you could scale that if you wanted to for a project or something like that. Now, I'll see you next time when I bring the 5.7 against these lithium iron phosphate cells that I have here. These will be going on my spinal battery version 2, again, that I'm working on in the background. And as mentioned, I'll put these gradient lattices behind them just out of curiosity to see if the cells with the gradient lattice provides any sort of ballistic protection against potential handgun rounds. So I hope that you enjoyed this research. It was definitely a lot of fun trying these different calibers, trying my gradient lattices with Formlabs machine, and shooting some aluminum, because I've never done that before. Again, the best free way to support the channel is just leaving a like or a comment, even if it's just, thanks for sharing the video. Always helps my video reach more people out there. It helps the channel grow, and will eventually help me fund more of my projects. Of course, this is all funded by my day job and a few light sponsorships here and there. But until I make those custom pads shaped to my system and test these, I'll see you all in the comments below.